As you can see, I'm here on Apache Spark's official website, and in this video I will be talking about what Spark is and how does it fit into the whole ecosystem of big data and large scale data essentially. Reading this definition right here by Apache Spark, they say that Apache Spark is a unified analytics engine for large scale data processing. So as we move further along this video, we will talk about and break this definition down. But one key thing to remember here, the one key phrase is large scale data processing or big data processing. To get it sort of a visualization of what this would mean, I have drawn a really not coherent image of a business model. So think about it this way. We have a business of selling tomato soups, and it is a really big business like the big Campbell guys, and quite a famous business too. And we're bringing in lots and lots of tomatoes every single day in our warehouse to make soup out of it. So we are bringing lots of tomatoes, putting it in a warehouse, cooking them, and then making soup, right? So to make soup out of these tomatoes, there needs to be some processing that needs to be done, right? You can, like raw tomatoes, they need to be cooked, they need to be peeled, they need to be, spices needs to be added to them, to the soup. So all this processing needs to be done on our tomatoes and to finally get soup out of it. But what happens when you have this whole ton of tomato, like a warehouse full of tomato, but you do not have the right processing power? You do not have the right people, you do not have the right tools. What happens then? Like, consider a scenario where you do not have people delegated to cut the tomatoes, to peel it, and then to cook it. People are just randomly picking in tasks, and they are doing different tasks. So a person is also doing the cooking, also doing the peeling, also doing the chopping. So this is a very haphazard manner of delegating the tasks and converting that input to our output. And what happens to our business is that we are experiencing a loss because we are spending so much of our efforts and time into bringing amazing input, amazing red tomatoes, and then we are not efficiently utilizing all of that tomato to make soup out of it. But what happens if we bring people in, someone like a manager? That's me. Let me move down here, right? As I said, some processing needs to be done on my tomatoes to make it into soup. So what I do, my business is experiencing loss. So what I do is bring in a manager. And what that manager does is, it sees that I have around like 50 people working with me for making that soup. But there's no alignment of tasks between them. So what this manager is going to do is say, okay, I'm going to put 10 people into peeling, around 25 people into cutting, and then 20 people or 40 people will be doing the cooking. Now, I just drew this line in between them because they don't have to be in the same space. Like, they don't need to be cooking in the same kitchen to be, cooking. They can be cooking soup in different kitchens, but still be doing the job that is given to them, that is cooking the soup. So this makes my business more efficient because now that I know that all of these people can handle, say, like 10 pounds of my input, I have an idea of how can I process more input, and I also made that task more easy. I assigned the task to people, and I also, one important thing that the manager or me, whoever it was who did, was that they assigned it the order that tasks need to be done. So first we need to cook, then we need to cut, then my business needs to cook the tomatoes in order to get the soup. Right, so this is a very clear business model. Talked about our super successful soup business, a lot of S's. We are back at Apache Spark's website. Again, looking at this definition: unified analytics engine for large scale data processing. I'm a visual person, so I'm going to move to a diagram to explain what that means. So as we looked in our previous example, we had our manager who sort of grouped people into these like bins, right? So I'll assign specific tasks to them and said that, okay, you need to do this, you need to do this, and like, you know. So what Spark does here is it takes in data from wherever it is stored. It could be HDFS, it could be S3 buckets. So it takes data, large amounts of data from wherever it is stored. And then it sees what processing needs to be done on this data, whether it needs to be cleaned, whether I need to split it with certain delimiter. So it sees what sort of processing needs to be done, and then since the data is so large, it cannot be computed on a single machine. Like the data that the businesses today, business data intensive businesses are getting today is just beyond one can imagine. So it's bringing in additional computers, additional help to process that data. And Cluster Manager is sort of the key in taking that data and understanding what my application needs. So application in this case, in going back to the soup example, consider this as like my business model of building soup, or of like making soup. So my business model says that I need to make soup. So my Cluster Manager is going to take in that information. Okay, I need soup. I need to make soup. I need these tomatoes. And then it's just going to distribute the work, and it's going to distribute the processing, whatever my business model told me. Suppose my business model told the manager that I need to cook first, and I need to cut first, and I need to peel, and then I need to cook, as we were doing in the diagram here. Peel, cut, and cook. So my business model is telling my manager it needs to be done in this way, and then my manager is distributing that workload between people in what Spark uses is called a directed acyclic graph. So it is a directed acyclic graph. It is directed from one step to the next in an acyclic manner. So your data is never really changing. So when I'm moving in this diagram right here, if I'm peeling, then I'm cutting, and then I'm cooking, from this stage, I'm not going back. I'm not going to be peeling tomatoes after I cook it. It's an acyclic order, and then I'm going to get soup, which basically my manager, I'm going to take this from all of my nodes, and I'm going to put it back to my manager and then give it back to the model, right? So the manager will take that task and then distribute it and then bring it back to me, or to bring it back to the application. To the installation for running and configuring Spark. The first thing we need is obviously Spark. The second thing that we need is Java in our computer system, because Spark gets compiled into Scala code, and Scala is written in Java, so that's why we will be needing a Java environment setup to configure our code. And we also, well, again, Hadoop is not necessary, but I think why I am installing or giving you a reference is because sometimes Spark can sit on top of Hadoop, and Spark can use Hadoop's HDFS, which is Hadoop's let me draw it in a haphazard manner here. Hadoop distributed file system, which stores data. So this is going to store all the data, and then we can use Spark on top of all this data to do pre-processing. So pre-processing, pre-processing is done with Spark. Alright, so I'm just going to download Hadoop for that, and I will be running or giving an example of running a machine learning model and have it scaled to different nodes or different worker nodes, so that's why I will also be needing Python. Again, these two you don't really need to have, but this is what I will be using for my system, and I also recommend that you download it in this order, so it'll be easier for you to configure and run for the first time. And then once you have experience, you can definitely play around with it. So let's just go back right here, click on downloads, and well, I'm already on the download page. Choose a Spark release. So there are two releases, 2.4.7 and 3.0.1. I would prefer downloading or recommend downloading 3.0.1 because several libraries that we might use later do not or are not well supported by 2.4.7. So I'm just going to 3.0.1 and pre-build for Apache Hadoop 2.7. Let's just download from this mirror site right here. Okay, so it seems like it's going to take a bit, so I'm just going to pause the video. It is installed, and I have unzipped it and put it into a folder in my D drive. Currently I'm in my C drive. My C drive doesn't have a lot of memory, or I like to try and store it. So you can go to and extract it via 7-zip, and you know, you can like extract here and choose the folder. So I put it in my D drive, which is right here. Let's go to Spark. Put it in Spark. I'll have to unzip it again. It's a tar file, so I'm again going to use 7-zip, and I'm going to extract them here. That I got, I'm going to go into this folder. I'm going to cut all of these files right here. Come back to Spark, paste it here, and delete this folder. You know, it's not going to help me in any way, especially if I'm trying to access commands from command line or git bash here. So just looking around this folder, we have a bin which will have all the shell commands and all the command line files, so we can run this from, you know, a terminal. And then we have a configuration folder which has all these configuration files for configuring the slave nodes, the log properties, the Spark environment. So these are templates. We can basically like edit them as we want. Great, so looking back on this, we already have Spark installed. Going down, we now need to install Java, Hadoop, and Python. Well, I already have Java installed, and I think most of us already do, but I'm just going to give us an idea of where we can download it from. So this is the Java JDK downloads page, and you have like Java JDKs for various different versions, and all you need to do is really just download, click on this download button right here, and it will start downloading. The process should be similar to how we had it for Spark. Now, going back to Hadoop, just type in Apache Hadoop, and you will basically come on this site right here, go to the downloads page, which is this page right here. You can download any of these versions. I currently am running at 3.2.1, so just for the sake of making this a little more intuitive, I'm going to download this folder right here. So as we can see, it's a similar format as our Spark was, and all you have to do is just click it on this link, and you will have a file downloaded. I'm not downloading it because I already have it, but I am going to show you how it will be downloaded. So I put it in my D, and I put it in this folder, Hadoop 3.2.1, and here are the bin files, which will again have all these commands, and then you have these libraries. It's pretty similar and pretty easy process. Going to Python, again, just type in Python, click on the downloads page. You will have all of these downloads for like different versions. You can download the new version starting 3.8.6 till above. Just a little quick reminder or note here is that while later we are working on with PySpark, there are certain versions of PySpark and Python which are not compatible, so just to be sure that we are going to be working with the same versions and make our code running so we're not dealing with those frustrating errors, let's just download maybe 3.8.1. Yeah, so this seems alright. So this is what I'm running right now, so we can download 3.8.1. So just click it on right here, and on this 3.8.1 page, scroll down to the bottom. Oh, hello. So then we can download the x86-64 executable installer. It's just going to be an exe file which we can run easily. I already have Python, so I don't need to go through it again. Alright, I'm just going to, so here's my Python. So it will be an exe file. You have to execute it, choose a folder for it, and this is in my D drive. It's how it's going to look like. let's look at the checklist. We have Spark, Java, Hadoop, Python. Well, downloading and putting them together shouldn't really be a hard step, especially like Spark and Hadoop are pretty similar. I already showed you the process for Spark. Python is an exe file and Java is a simple JDK exe, so all you have to do is just to run those. Now, one important thing that we need to understand here is that, as I mentioned earlier, that Spark is built on top of Scala, which in turn gets compiled into a Java code. And Spark is also utilizing HDFS, or can utilize HDFS. We need to make a sort of way so that each of these programs know where they're installed. So because my Spark needs to know where Java is installed in order to configure, while it is running, in order to configure the code into a runnable code, it needs to know where Java is, and it needs to know where Hadoop is. And when I'll be using a machine learning model on Spark, I will be using a library in Python, and I'll be writing my code in Python, so that Spark library needs to know where Python is, and Python in turn needs to know where Spark is. So what we can do for that is configure our environment variables. It's a pretty common step. Just look for environment variables. I just typed env on my Windows search bar. Here we are. Well, basically what we'll have to add are all these shell commands and all these command files. So whenever we type Spark, for example, on our command line prompt, it knows what shell or what command file to run. So what command window command prompt to run. So as you can see, well, I already have my Hadoop home and my user variables. So here's what you do. You set up a variable and then you set up a path for that variable. So this basically tells it where my folder is, so we can go and look. Data D, Hadoop 3.2.1. Now if I were to look in my path, we can see we have this path Hadoop home/bin. Now this is where all of my window command files and all of those commands which I can run from my terminal are going to be. So just so my system understands where all of these programs are. I also have, I'm just going to delete this and I'm going to show it to you how we can do it from our, so I'm going to click on new, I'm gonna type Spark home, my variable, so it's on data, it's Spark right here. So I need to enter wherever I have this whole like folder, right? All of this folder is a D Spark. Awesome. So now I can edit my path to add that bin, which is going to be at, this is me referencing my Spark home. Percentage sign / bin. Okay, so this is what you are going to do for each of your Hadoop, for Spark, and also for Java right here. As you can see, I have this Java home. This is where my JDK is installed, and it will also have a bin folder. Whenever you run that executable command, it's going to have a bin folder, and that's where you will be entering your Java home/bin. Here it is. And similarly, you'll also have to do that for your Python as well. I think I put it in my system variable. Okay, so we already have Spark home set up, we have Hadoop home set up and Java home set up, and we also set up the path for each of them right here. Now I'm looking for my Python path, so my system knows where that file is. And one thing to note here is a Python, when my system is running Python, they're basically, okay, so this is 3.7, let me just go to 3.8. We don't have a bin folder here, but what it runs is essentially the python.exe file. So I need to provide the path to this, to run Python should be python 3.8/exe or python.exe. So just added it, I think, to system variables instead of user variables. And there really is no difference except the fact that your system variable is available only to or the system variable is available to everyone, but the user variable is available only to you. So here is my Python environment and like the .exe file. This is where it exists, so my system will know that the exe is here. And whenever I type, let me just go to command prompt. Whenever I type Python, I am in my Python environment. So let's just say hello, awesome. Just exit. This is a good way of checking whether you have everything set up or not. So Hadoop version, just rechecking. Okay, so we already have a Hadoop version. So it says that it's the Java version because the Hadoop is also built on top of Java. So it's basically running Java as the runtime. Okay, so it seems that we have everything set up. I can enter a Spark shell to go into my Spark session and see what do we get here. Okay, it is taking a bit of time, which it actually usually does, and it will give us quite a bit of logs because if I were to go back to Spark and I look at my configuration, I can change that here from the log template, and I can say that the root category only to print on the log screen whenever I have an error. So if I were to do this and save it with only log4j.properties, it would only be printing error lines instead of info. But like I don't have to do that right now. You don't have to do that. It's just a little bit of tweak that you can do. Okay, Spark version 3.0.1, that's what we downloaded. So great job, it works. Just ending this session there. Alright, now who is here for the fun part? Now that we have everything downloaded and all the environment variables and the path set up, the really fun part is to start our Spark cluster and have workers registered to our master and see it running, have data come in, have it distributed across clusters. It's just so fun to see. So the easiest way to do that on Windows is what I will be talking about in this part. So let's just open command prompts. I have like 4 different command prompts running, and take note of this command because this is the easiest way of configuring and running your Spark cluster with the Spark master. So however many worker nodes that you have and that your system can really handle. Spark class, which is one of the command file, and this is Spark bin right here. So I'm just running it via my command line, and I'm going to give it some additional instructions to know where to know that I'm going to run my master, or to know that I'm going to run my worker, or whatever my worker and master should run. Or to Apache spark.deploy.master. As we remember, it's going to give us some logs because in our log4j properties we have it set up to info instead of error. So all of these info is going to come into me, and master says that it has been elected leader. Well, good for them. Good for them. Let's open localhost and see it running. So it's going to be running on localhost 8080. Awesome! Isn't this super cool? So we have a master at Spark. Just going to copy it. We are going to need it later. Applications, no applications connected right now. 0 applications. So this is basically like all of the processing coming in. So all of the things that needs to be done is basically an application. Workers that do not have any worker connected. Well, this is a good time to add a worker, so let's do it. Again, take note of this command. Easiest command to and efficient, right, to run your worker. Spark class or .apache spark.deploy. There's one additional step that this is going to need, which our master didn't, is specifying whenever our master is running, because in order for the worker to connect to the master, the worker needs to know where the master is. Okay. That's my address. I typed into it. I'm just going to get some logs, info, workers started with security manager, resource utils, successfully started worker UI on port 8080. Come on. So this is our worker, and it has 8 cores. It has quite a bit of memory. Well, if this isn't still refreshing, I hope I didn't close it. Okay, well, sometimes that does the trick. Alright, so as we see, we have a worker, which is the one right here. ID is 32713, 32713. Let's, for fun, just add another worker to it. The same command, I'm going to use the same command that I used, spark class org.apache.spark this address. Okay, not this address. Didn't know when I copied that. Okay. Looking at the logs is pretty always important to see if everything is working alright. Okay. Registering worker, so it has registered another worker. As you said, 32784. Let me refresh this. Okay, 32784 must be running on another port. So this is on, let's see, this is on 8082. So if I were to go on to localhost 8082, I would get this. Okay, so that was it. That was running our Spark worker with a Spark master, and in the next part we are going to run an actual application, an MLlib application, and see how it scales. Okay, so congratulations, we finally have a Spark cluster set up at this particular location with 2 worker nodes connected to it. One worker node with this ID 32713 and 32784. Clicking on it, there really is nothing going on right now because we do not have an application connected, but that is what we're going to do in the future. What I will do is I will be running a MLlib model, which I will be exporting from PySpark, which will need Python, and that's why earlier we installed Python. So we will be using MLlib, and we will be using a decision tree model from MLlib. I will be trying a very simple model which uses a diabetes data set to figure if a person has diabetes or not depending on certain features. So really fun stuff to come, and it's like really interesting to see when the processing that is being done is scaled into different workers, and see if adding more workers really reduces that time or not, so we can think about how if we are running like a small batch of work, we might not need so much processing power, but if we are running a really large amount of data, like tons and gajillions and bazillions of data coming in, then is an optimal situation of scaling into different, or like spreading the work to different nodes. So yeah, fun stuff to come ahead, and hope that was a pretty short or pretty long introduction to Spark, and I hope that you have it configured. There are a few things which I'd like to mention is if you're getting errors, the first thing you'd like to sort of check is if your PySpark or your Spark and your Python and Java are able to communicate with one another or not. And an ideal way to do that is just going on the command line and typing Java version, Hadoop version, Spark, and Python, and just seeing if that is giving you an error or not, if that is being recognized as an actual command, or like if your system knows where they are. And another common thing that happens a lot is just just not working across different versions. So I remember I was running into an error where my PySpark was not configured, or my PySpark actually did not support the Spark version that I was running, so I had to downgrade to a different Python environment. So yeah, so those are the two things that you can take care of, and if there are additional things, you can always check the logs and see what kind of error you are getting, and if this is something that you can change from your environment path and environment variables, that because that is one really common error. Right, so I hope that you have it successfully running, and see you soon. Bye.